Okay, this is the review for our first quiz, which is over chapters 1.1 to 1.3. And remember, 1.7 was the linear models and regression. So this whole first part is no graphing calculator. Write the point slope form and slope intercept form equations for each line. So you need to study that y minus y1 equals m times x minus x1. That's point slope form. And slope intercept form is y equals mx plus b. All right, so we want the equations for the line that passes through these 2 points. So first you need a slope. So I usually just do first point minus the second point. So I'm going to do 4/9 minus 2/3, change in y, over change in x, 1/3 minus 5/6. And then we need to work on this math. So we can get common denominators separately in the top and the bottom. So I'm going to keep 4/9 as it is. Change 2/3, multiply by 3/3. So make that minus 6/9. In the bottom, the common denominator is 6. So I'm going to multiply 1/3 by 2/2. So 2/6 minus 5/6. This subtracts to negative 2/9. This subtracts to negative 3/6. The negatives can cancel out. So now it's 2/9 times 6/3. And things cancel, by the way, right? Like 6/3, that's 2/1. So this is 4/9. I am expecting you at this level of math, AP pre-calculus, to be able to work with fractions. I know we can get a bit rusty, but if you're careful about it and you're neat about your work, we should be able to work with this. Please let me know if you want to come in and just practice fractions. There's absolutely nothing wrong with doing that. All right, so point slope form. I'm just going to call this PS, point slope form. You can use either one of the 2 points. It does not matter. I'm just going to use the first one. So y minus 4/9 is equal to the slope, which is 4/9, times x minus x1, which is 1/3. So this is point slope form. That's the easy one. We use it a lot in calculus too, so you need to know that. The only reason I want you to do slope intercept is because, again, I need you to be able to work with the numbers. Sometimes we will be looking for answers that are in slope intercept form instead of point slope. So our steps would be distribute the 4/9. So y minus 4/9 is equal to 4/9 x minus, nothing cancels top and bottom here, so it would be 4/27. And then you need to add 4/9 to this side. Instead of adding 4/9, though, you need to change that to 12/27, multiplied by 3/3. So it's y equals 4/9 x. And then what's negative 4/27 plus 12/27? That's positive 8/27, which does not reduce because the factors of 8 are 2, 4, 1, and 8. None of those go into 27. All right, next problem. We want our line to pass through this point. So there's our x1, y1. And it needs to be perpendicular to this line. So we need to figure out the slope of this line so that we can write what our perpendicular slope would be. All right, so to get the slope of this line, go ahead and get it into slope intercept form. 2y is equal to, I would add 3x over, and then I would divide by 2. It's only the 3/2 that we care about. So I want to be perpendicular to a line with this slope. So the perpendicular slope I need to use is the opposite reciprocal of 3/2, which is negative 2/3. So again, point slope is the easy one. You just write y minus y1, which is 4, equals slope, which is negative 2/3, times x minus negative 2. Make that a plus 2. There's point slope form. Slope intercept form is just being able to do the math and kind of work on this. So distribute the slope through. Y minus 4 equals negative 2/3 x minus, this is 2/1 times 2/3, so minus 4/3. And then you're going to add 4 but you need to change that 4 over 1, change it to 12 over 3, so it has a common denominator. So y equals negative 4 thirds x. Negative 4 thirds plus 12 thirds is positive 8 thirds. I don't know why I keep getting 8s there. So that's our slope-intercept form of that line. All right, now we want a line that passes through the points 9, 12, and negative 1, 12. So let's find the slope again. 12 minus 12 over 9 minus negative 1. That's 0 over 10, which is 0. If it were 10 over 0, I would get undefined. A slope of 0 means we have a horizontal line. We could technically write the slope-intercept form. The reason I said if possible is if you have a vertical line, if the slope is undefined, you can't write a point-slope form or slope-intercept form equation. So let's still write point-slope form. It would just be y minus, pick any point, y minus 12 equals 0 times x minus 9 or x plus 1. And then I guess technically slope-intercept would be like y equals 0, x plus 12, or you could just make it y equals 12. This last problem has a y-intercept of 5. I like to write those as intercepts as ordered pairs. So if it's a y-intercept, it means the x-coordinate is 0 and the y-coordinate is 5. It's perpendicular again, opposite reciprocal to the line x equals 3. Now this is a vertical line. Its slope is 0. If I want to be perpendicular to that, opposite reciprocal doesn't really work, but what's perpendicular to a vertical line? A horizontal line. So I want the perpendicular slope to be 0. Oh, sorry, what did I say? Vertical line slope is undefined. Sorry, not 0. The reciprocal of that is technically 0 if we think about having no rise and all run versus all rise and no run. So I can say y, for my point slope form, I can say y minus 5 equals 0 times x minus 0. Just leave it unsimplified like that if you want. Or your slope-intercept form, again, would be just y equals 0, x plus 5, or that's just y equals 5. Determine whether or not each relation is a function. Justify your answer. Do not give the vertical line test as the justification. So this is going to be tedious, but if you keep writing what your official justification is, I would hope that you would definitely get that point then on the quiz and the AP test. So I'm going to either write every input has exactly one output or some inputs have multiple outputs. All right. Remember, it's a function if you have y to an odd power. It's not a function if you have y to an even power. So this is y to an odd. So actually, let me try to color coordinate this. So this is a function. I'm going to do green for function. Function y because every input has exactly one output. The next one is an absolute value graph where the absolute value is around x, forms one of those like V-shaped type things. So this is also a function. Every input has exactly one output. And again, I'm telling you, I know this is annoying to write. I'm going to do it as many times as 6 times, just like you will. If you don't write it, you might lose this point on the quiz if you haven't been practicing what to say. What about this one? Y is to an even power. So that's not going to work because we would get a plus or minus if we solved for y. So this is not a function. And I'm just going to say, you could say every input does not have exactly one output, or you could say some inputs. I always say some instead of every because there's usually one point that maybe is fine. So some inputs have multiple outputs. You don't have to give an example, but you could plug in any number, almost any number for x, and show that you get to generate like a plus or minus y. If the absolute value is around the y, that's some sort of an absolute value graph that opens sideways, failing the vertical line test. But officially, I will say not function, because some inputs have multiple outputs. If you have an absolute value, or I'm sorry, if you have a square root already built into the function, like you didn't put it there, it didn't start out as a y squared, it's already a square root function, this graph would do something like this. So yeah, that passes vertical line test. This is a function. And the reason is every input, in this case, every input gives you a negative y value, negative square root of whatever value. So every input has exactly one output. Final one, y is a rational function. You might remember these from Algebra 2. You had to do like all those fun vertical asymptotes, something like this, right? That passes the vertical line test, but there's no issue here. Y is not to an even power. There's no absolute value around the y. That's about all that we'll see. So this one is a function. And I only have to write this one more time. Every input has exactly one output. Okay, arithmetic sequence. So this is something you might have done back in Algebra 1. It likes to pop up on our AP exam, so that's why I've included it here. Write the next three terms of the arithmetic sequence, then find the 100th term. Now, I won't always ask you for the 100th term, so you need to know the formula in general. In general, you can get to any term k. This could be 100th, 1000th, 50th, whatever. If you start at some starting, oh, sorry, not n. Let me use a. Sorry. You can get to any a sub k by starting at some a sub n. Usually it's 1, but we could start wherever. And adding to that the common difference times the different distance between these two terms, k minus n. Like, if you're trying just to go from term 1 to term 2, you just add the common difference once and you get to the second term. But if you're trying to go from term 1 to term 100, then you're going to add that common difference 99 times until you get to the 100th term. So for these purposes, I'm going to say this is A1, A2, A3, A4. First, find the pattern. We're told these are arithmetic sequences, so that means that the common difference should be what you get when you subtract any two consecutive terms, and order matters. This comes out to positive 3. You could do that for any of them. 1 minus negative 2 is also 3. 4 minus 1 is also 3. So you don't have to show it all 3 times, but the fact that you're just adding 3 to get to the next one is going to help us find the next 3 terms. So next 3, add 3, you get 7. Add 3 again, you get 10. Add 3 again, you get 13. So there's that. What is the 100th term? I don't really want to add 3 until I, get to 100. So instead, I'm going to say, okay, we could start back at A1, if that's easier to remember. Add the common difference, 100 minus 1 times. Because you're just saying that's how many times I would have to add 3 until I landed here. So the first term was negative 5. We said the common difference was 3, and we're doing that 99 times. You do have to do a bit of math off to the side here. What's 99 times 3? Now you could do 100 times 3 and then subtract 3, or you could just do 3 times 9 is 27. 3 times 9 is 27. Add 2, 29. But if I did 100 times 3, I'd get 300, and then I'd just subtract a 3 from that. Anyway, 197 plus negative, or 297 plus negative 5 is 292. That's the 100th term. This math is still faster than keeping track of if you've added 3 99 times. So know the formula. I could have said A4. started at 4 plus 3 times 100 minus 4, and then gotten to the same answer. All right, so let's find the common difference for this one. 218 minus 220 is negative 2. That means, yeah, you're just subtracting 2 to get to the next term. So the next 3 terms, just keep subtracting 2. So 212, 210, 208. Those are the next 3 terms. What's the 100th term? I like starting at 1, so I'm calling this A1. So A1 plus D times 100 minus 1. And so that's 220 minus 2, because that's D, times 99. 99 times 2, 18. 18, carry the 1. 220 minus 198. Oh, we get all the way down to 2. No, we don't. Wow. That'd be 200 minus 198. 220 minus 198. I'm getting ahead of myself here, so do all my fun math. That is 22. Double check my math because it's the end of the school year, as you can see, and my brain is fried. So add 22 to this. Yeah, I get 220. Okay, so 22 is my 100th term. You can see, I understand sometimes our math gets a little bit out of our control. We can double check that. If I had time on a quiz to go back, I would maybe double check this again, add these together, and make sure I get what I'm supposed to be getting. But I think that's okay. All right, use this graph to answer the questions below. The points labeled A, B, C, D, and E are either x-intercepts, relative extrema, or points of inflection. List the points by letter that fall into each category. So where are the x-intercepts? They're the ones that are on the x-axis. So I see A, C, and E. Where are the relative maximum or multiple points? Where's the relative minimum? So B is the relative max. C is the relative min, D, change from decreasing to increasing. Point of inflection is where we change concavity. Now, it's often in the middle of the graph, but it's not always. So just keep that in mind. Some people say, oh, it's the middle, so it's that one. But that's just because we went from concave down to concave up. So point C. Identify the intervals on which the function is increasing, decreasing, or constant. Just the function, not the rate of change. Just is the graph going up, down, or staying the same. So the graph is increasing from negative infinity to B, and then also from D to infinity. And the graph is decreasing in between B to D. You wouldn't say B to C, C to D, because it's still decreasing at C. So don't break it into parts just because there's a point there. On the interval negative 2 to 4, so from here to here only, not these ends. So I'm covering up these ends on my screen. Name the points, if any, that represent the absolute max and the absolute min. So ignoring all of this, just this part, the absolute max is right there, and the absolute min is right there. So absolute max is point B. Absolute min is point D. It's just the actual highest and lowest point just on that interval. Okay, get my marks off of here. On the interval negative infinity to infinity, name the points, if any, that represent the absolute max and absolute min. Now, if they don't give me a closed interval, there's no answer to this, because what's the highest point on the graph? There is not one. This goes on forever. And what's the lowest point? There's not one. It goes on forever. So if any is because there are no absolute extrema on an open interval. Has to be a closed interval where they include endpoints and tell you where you're starting and stopping. Determine the interval or intervals for which the function is concave up and the intervals for which the function is concave down. Also, state whether the rates of change are increasing or decreasing. So I already know this answer. Concave up, rate of change is increasing. Concave down, rate of change is decreasing. Do not overthink it. Now we just have to find the right sections. Looks like it's concave down on this first half until you hit C, and then it switches to concave up. So, excuse me. So I'm going to say negative infinity to C is concave down. So concave down from negative infinity to C. And remember, concave down, rate of change is decreasing. And then concave up, just double check my picture again. Yeah, from C to infinity, this whole graph is concave up. And that means that the rate of change, because it's concave up, rate of change is increasing. On which intervals are the rates of change positive and increasing? So we already know where the rate of change is increasing. It's increasing on C to infinity. So we're looking for a concave up section. What about the rate of change being positive, a positive slope? Positive slope just means the graph is going up. So instead of writing increasing, I'm going to write H or F, or whatever. F goes up and it's concave up. So something like this is what we're looking for. So find that section. Going up, concave up, yes, D to E, but also E to beyond. So D to infinity, that whole section is increasing and concave up. Where are the rates of change positive and decreasing? So going up, but concave down. Going up but concave down looks like that. So find that section of the graph. Right there in negative infinity to B. On which interval are the rates of change negative and decreasing? So negative means we're going, so instead of going up and down, sorry, I'm mixing up all my terminology here. I'm looking for positive slope, concave up, concave down. And then on this one, I'm looking for a negative slope and concave up. So that means I'm looking for, do it like this, equals that, equals that. Okay, so looking for that section of the graph. Concave up, but the graph is decreasing. So I think that's C to D. I can get my pen to switch there. Rate of change is negative and concave down, decreasing. What would that look like? It would look like that. So that is B to C. All right. Find the average rate of change given on the closed interval. Remember, if the interval is A to B, your formula in general for average rate of change, AROC, which is just slope, is F of B minus F of A over B minus A. That's just change in Y over change in X. So here's our table. I want slope between -3 to 8. So use just these 2 points. AROC is equal to F of 8 minus F of -3 over 8 minus -3. That's 5 minus 20 over positive 11. That's -15 over 11. Difference quotient. Now I'm giving you the difference quotient here. You do not have it on the quiz, so make sure that you memorize this. If the function's quadratic, we have to go ahead and do difference quotient. So let's get this set up and just carefully go about our work here. 4 times x plus h squared minus x plus h plus 3. That's f of x plus h minus f of x all over h. Now we carefully FOIL everything out, so I'm going to keep the 4 out here for a second. This is x squared plus 2xh plus h squared minus x minus h plus 3 minus 4x squared plus x minus 3, all over h. Remember to write the all over h part, otherwise it's a false equivalency, and you wouldn't get credit on, say, the calculus exam. Okay? Now distribute the 4 through. 4x squared plus 8xh plus 4h squared minus x minus h plus 3. Maybe you've canceled some of this out already. That's okay too. Anything without an h should cancel. So positive 4x squared minus 4x squared minus x plus 3 minus 3. Sometimes I circle what I have left so I don't lose track of it. You don't have to show me the factoring out step, but what you're doing is saying I can factor an h out of the remaining terms. And then this h is allowed to cancel with this one. So the secant slope can be found by calculating 8x plus 4h minus 1. Remember, if you have a linear function, then you don't have to show much work at all. So this is a linear function because you can divide by 2. You can say 10 divided by 2 is 5x plus 18 divided by 2, 9. 5x plus 9 is a linear function for sure. And the slope between any 2 points is just 5. So save yourself the effort and the work when you see a linear function. Okay, domain and range. Remember, you can go back to that packet and kind of practice those too. For a square root function, we set the expression greater than or equal to 0 for domain. And then just solve that. X is greater than or equal to negative 6. That would be negative 6 to infinity. For the range, it's a square root function. It hasn't been shifted vertically at all. So you can get 0 out of a square root function and anything positive. Now the domain for this one has both a square root and it's in the denominator. So x plus 6 still has to stay positive, but it can't equal 0. So x plus 6 is now just greater than 0. X is greater than negative 6. That just changes the answer from 23 to be parentheses negative 6 to infinity. And for the range, this is a fraction, so I run through my checklist. Because there's no x on the top, y can't be 0. And then you have 1 over a square root. That's always a positive over a positive no matter what. So you can only get positives out of this. So our range is anything from 0 to positive infinity without including 0. 25 is almost the same thing. I just put a negative 1 on the top. So the domain is still the same. It would still be x plus 6 needs to stay greater than 0, x greater than negative 6, so negative 6 to infinity. There's no difference for the domain between 24 and 25. Slight difference for the range. It's still true that y cannot equal 0. And then we have a negative 1 over this radical, which is always positive. So we have an always negative over an always positive, which is negative overall. So negative infinity to 0 is the range for that problem. All right, if you have a quadratic, you need to sketch the quadratic for the range part. So this is a quadratic that's been shifted up 8 units and it opens up. So you need to know that the vertex is sitting at 0, 8. For the domain, that's easy. Any quadratic, linear, or polynomial function is all real numbers. And the range, we go from positive 8 up to infinity. And then if we have square root of x squared plus 8, this one's kind of tricky, actually. The domain is like, okay, well, x squared plus 8 needs to stay greater than or equal to 0. Well, x squared plus 8 is always positive, right? Or if you tried solving this, you get like you run into like an imaginary number. So this is just all reals. You can plug in anything you want for x, and you're going to get something positive that you can then square root. What about the range? If you plug in 0, you get radical 8. If you plug in plus or minus 1, you get radical 9. If you plug in plus or minus 2, you get radical 12. So the numbers are just going to keep going up, right? 0, 8 is the lowest number that you'll get. So this one we had to think out of the box a little bit. So this range is radical 8, or I should make that 2 radical 2, right? And then it'll go up to infinity from there. What if it's 8 minus x squared? So that graph has been shifted up 8, but now it opens down. So the domain is still all real numbers. The range is negative infinity up to positive 8, including positive 8. All right. What about this? Now notice that I have this 10 minus 2x expression, and it's just under different kinds of roots. So if you have an odd root, remember the cube roots kind of go on forever like this. They don't have starting and stopping points or restrictions. So the domain is all real numbers. There's no inequality to solve there. And as long as you have a linear expression underneath your cube root, which is all that I would give you, this graph will continue to just go up to infinity or down to negative infinity on both sides. So the range is also all reals. If it's a square root, now we have to say, okay, well, there is a starting point. We can't square root negatives. So for the domain, 10 minus 2x has to stay greater than or equal to 0. You can solve this. You're dividing by negative 2, so you have to remember to flip the inequality around. Or you can move the x to the other side and you get the same thing. So x is less than or equal to 5. So negative infinity to 5 with a square bracket. And then the range, again, this is a square root function. It has not been shifted vertically. It's been stretched and shifted horizontally, but it still is one of those that like starts somewhere on the x-axis and goes up. So 0 to infinity. And then finally, what if we have a cube root in the denominator? So remember, there's no restriction to the cube root itself. So that was all reals. But as soon as you put it in the denominator, it's the same idea as like, what if it were just 3 over 10 minus 2x? So we just have to make sure that 10 minus 2x never equals 0. That means that 10 can't equal 2x and 5 can't equal x. So domain is anything except for 5. That way we don't divide by 0. And then for the range, we're saying back to a fraction. We're saying, all right, top doesn't have an x, so y can't equal 0. And then we have 3 over this cube root. Now, a cube root can be plus or minus. 3 is always positive. So sometimes you'll get positives and sometimes you'll get negatives. That means that the range is everything except for 0. All right, that finishes the calculator portion of this video. I know that was pretty long, lots to practice. Our quiz is not this long, but I just like to give you plenty of practice for that quiz.